about inverse variation in being able to find relationships between two different numbers in a table, okay? There's two real types of variation that we're going to be dealing with. One of them is called direct, and one of them is called inverse. I'm pretty sure, I'm not positive, but I'm pretty sure you guys deal with direct variation in Algebra 1 right after you get done talking about equations of lines. Because direct variation is in the form y equals a times x, and inverse variation is y equals a divided by x. All right? So direct variation is when you have y equals a times x. A is kind of like the slope, and inverse variation is a over, or being divided by. So you'll notice that one of these is a multiplication operation and one of them is a division operation. But in both of these, a stands for, the words behind it are called the constant of variation. So a is the constant of variation, okay? Now, one thing I want you to kind of think about with direct variation means that one variable directly influences the other variable, which means that as one variable goes up or increases, so as one variable increases, the other variable does too. And I'm going to put increases in quotation marks because it could also decrease. So as one variable goes up, the other one goes up, or as one variable goes down, the other one also goes down. So it's basically just saying that one thing directly influences to go up while the other one goes up, or one thing goes down as the other one continues to go down. So they go the same direction. X increases, Y increases, X decreases, Y decreases. What's happening?
Nothing. I'll reference what
What happened?
yeah, Saxon band, Sarah, you were gonna read econ. I didn't want to go to econ, so I was walking around.
Where did you go?
Pretty much.
Cool.
Yeah.
Inverse variation.
Yeah.
Fun stuff. All right. So as one variable goes up, the other one will also go up. As one variable goes down, the other one also goes down. Now you should probably be able to figure out what happens with inverse. Inverse means as one goes up, the other one goes down, or as one goes down, the other one goes up. So this is just saying that they're not doing the same thing. So as one goes up, the other goes down. So as one goes up, the other one goes down. All right. And what I mean is when x is increasing, y is decreasing, or as y is decreasing, x is increasing. So it just means that one of them is going up and the other one is going down. It should be a pretty quick and clear idea on what you could decide as one is going up and as one is going down. The only thing that I want you to kind of pay attention to, and I'm going to put it right here because I'm going to show you an example of it, is be careful. Oops. Be careful with x being negative. So just be careful when x is negative for the direct variation, because it kind of makes it look like it should be inverse variation, but it's not. And I'll show you an example of what that looks like. Okay? Are we okay with what we see here so far? All right. So if asked, is it direct, inverse, or neither? So if you're asked, is it direct, inverse, or neither? The first thing that you should do is you should solve for y. If you solve for y and it's in the form of y equals something times x, it's direct. If it's in the form of y equals something divided by x, it's inverse. If it's in any other form at all, it is nothing. Okay? So like if I have something that looks like this, where it's 3y equals x. 3y equals x. I would divide by 3. I would divide by 3. So I would get y equals x over 3. X over 3 is saying the exact same thing as 1/3 times x, right? So is this direct, is it inverse, or is it neither? It's direct, right? It's something times x. Now it is that simple. That's what I'm saying. This is literally as simple as saying y equals something times x. If I have something that looks a little bit different, where I'm thinking xy equals 3. When I solve for x, or when I solve for y, I divide by x, so I get y equals 3 over x. Is this direct, inverse, or neither? Inverse. It's something over x. If you see a plus sign, or if you see a minus sign, it is neither. There's nothing you can do about it. There's no issue, there's no nothing. Okay? If you see something where you have an addition or a subtraction, you don't have to worry about anything. You just have to pay attention to when you solve for y, does it get into the form of something times x or something divided by x? There's your two answers. Okay? So that's one part or one way that I could ask you a question that looks something like these. The next thing would be, so it's going to ask you something like, is it direct, is it inverse, or is it neither? And it's going to give you an equation or a table. So with that table, you're going to look at something like this. Let's say that you have x and y. And you have an x value of 1, 2, 3, 4. So right now I'm trying to decide, is this direct, is it inverse, or is it neither? Now remember a couple things about direct and inverse. Direct means as one increases, the other increases. And inverse means as one increases, the other decreases. So if you look at this right now, are the x's increasing or decreasing? They're increasing. Are the y's increasing or decreasing? They're decreasing. Now, that means that we are guessing that it's inverse. So right here, x is increasing and the y is decreasing. So our guess is that it's inverse. I have not shown for sure that it is inverse. Just because one is going up and the other is going down does not guarantee that this is inverse. All it does is it gives us a good starting point. Okay? So this gives us the idea that it could be inverse. I might find out that it's not inverse. And if it's not inverse, then it's going to be nothing. Okay? So if it's inverse, that means it's going to be in the form of y equals a over x, right? The inverse formula is y equals a over x. So now all I need to do is basically find the equation. And if every one of those points works for the equation that I find, I'm done. Now, if I want to find the equation, it should be really, really easy, right? Because I just take this and I plug it into here for x and y, and then I solve for a. So I'm going to get 60 equals a, which I don't know, that's what I'm trying to solve for, divided by 1. So that tells me that my a value is 60.
Yeah.
Hey. Oh, okay.
Yeah. What are you learning about today?
Inverse variation.
Okay, see you later.
Okay, see ya. So a is 60. If our a value is 60, that means the equation that I've just come up with is y equals 60 divided by x. Now, if my formula works for every single one of those points, that means I have confirmed that it's inverse variation. If I have not, or if I find something that doesn't work, any of these points, if they don't work in my equation, it's nothing. Okay? But if I test this, I can put 2 in for x. So 60 divided by 2 is 30. That works. 60 divided by 3 is 20. 60 divided by 4 is 15. This works. So this is, in fact, inverse variation. I don't have to worry about it. Okay? All right? Any questions, issues, or concerns with that? Okay? So the next one, this one's the one that's a little bit tricky. The next one's a little bit tricky. Sorry, actually, the 8 minutes that we've been working have probably been pretty tough. So let's look at the one that I think is going to get people a little bit, because it starts out looking like it's a specific type, but then it just doesn't make sense. So -4, -3, -2, -1, and 20, 15, 10, and 5. So as we look at this, again, with the increasing and decreasing, it should kind of lead you in a certain direction. So if it leads you in this direction right now, you should see that the x's are increasing and the y's are decreasing, correct? You see the x's are getting bigger and the y's are getting smaller, which would lead us to believe that this is going to be an inverse variation. So x's are going up right now and the y's are going down, which makes us think that this is inverse. Okay, so it makes us think this is inverse. So we would do the exact same thing that we just did in the last problem. Now that being said, some of you can already see the relationship, right? What do I do to -4 to get it to become 20? Multiply by -5. Does multiplying it by -5 work for every single one of these? Yeah. So this is the common sense thing. That's the common sense piece I was just talking to you about. You have to know that. Okay, you have to see what's happening there So I need you to understand as we work our way through, I'm gonna show you like a next step of this. You have to be able to think about it with common sense, okay? Because right here, with inverse variation, that makes me think that it should be y equals a over x, okay? So y equals a over x. This would be, I take my points and I plug them in, so I get 20 equals a over -4 multiplied by -4. I get a equals -80. So that tells me my equation should be y equals -80 divided by x. Now that obviously works for point number 1, right? -80 divided by 20 is -4. -80 divided by by 15 doesn't work. So this right here would tell me that it's not inverse. We have to use our common sense here. You have to use common sense to know what's happening, okay? Because you have to be able to see, as you work your way through, that we've introduced a negative number. If you can see a pattern that looks like this, you should be able to come up with an equation. Because what's really happening here is these numbers right here, remember when I said be careful about the negatives? Those things right there are the things that are creating an issue. The fact that those numbers are negative is what's creating the issue, okay? So if we were to continue this, we would get 0 and 0, 1 and -5, 2 and -10. So we're still seeing that all of these numbers are opposite. That means we're multiplying by a negative, right? If you're multiplying by a negative, it would make sense that a positive times a negative would make a smaller number. The bigger the positive number is, the bigger the negative number is, right? So if you think about it like this, the bigger the x value, the bigger the negative number. So you have to kind of think about it in terms of that. This is the only special case where this happens. I would bet that this happens like 1% of the time. And every time that happens, you should be able to use your common sense with it. Okay? You should be able to look at this and say, well, obviously I'm multiplying by -5 every time to get the new answer. Most of the time it's going to work out and give you something that you're comfortable with. And it's going to give you something that you don't really have to think about too hard. Most of them are going to work out to be exactly like this question here, where you make your guess, you write your equation is correct, and you move on. Okay, so most of them are going to look like that. Any questions you guys can think about so far? Good. Very, very last thing, and again, super, super quick, is if I'm given something like, I could be told x and y vary inversely. Write an equation if x equals 3 and let's say 4 and 5. X equals 4 and y equals 5. Then find y if x equals like 10. So you're going to notice it actually gives you every single thing that you need, and it takes all of the stuff that we just did in our table into account. Okay, it tells you that x and y vary inversely, which means that you're using the equation y equals a over x. And they could do the exact same thing with direct. Right? Same exact thing could happen with direct, and it would just be y equals a times x. You need to write an equation if x equals 4 and y equals 5. So I'm just going to take my 5, plug it in for y. I'm going to take my a, plug it in for my x, plug it in for x. I'm going to find that a equals 20 for cross multiplication, and my new equation is going to be y equals 20 divided by x. And then the very last thing would be plug in x equals 10 and find out what y is. So 20 divided by 10 is 2, so y equals 10. Now this really is just like an Algebra 1 concept that we're just building on a little bit, right? So this is section 7.1. That's it for section 7.1. Do you guys have questions or issues or concerns that you can think about right this moment?